If the gas mixture is considered as a real gas mixture, we have to consider the compressibility of the gas mixture when we are considering PVT behavior. In most of the problems that is involved with compressibility factor, you will be given two properties most of the time, temperature and pressure of the gas mixture, and you will be asked to calculate the volume. How are we going to deal with these problems? In chapter 3, we discussed about compressibility factor. We are going to use the same concept here, and we are going to use the same diagram A15 for solving these problems. There are three approaches to discuss PVT behavior of real gases. One of the approaches is using a Bethe equation state rather than using ideal gas equation. However, we are not going to use this approach in this course. Two approaches that we are going to use in this course is called compressibility factor approach and case rule. Both of them are involved with compressibility factor. In compressibility factor method, what we are doing is we take the critical temperatures and critical pressures of the individual gases, and we are using those critical pressures and temperatures to calculate the reduced pressure and reduced temperature for each individual component gas. Then we are using figure A15 to get the compressibility factor for individual component gas, and we add them together using the shown equation to get compressibility factor of the mixture. So the compressibility factor of the mixture is kind of the weighted average of component gases weighted by the mole fraction. When it comes to compressibility factor method, you have to read the figure A15 several times. However, when it comes to case rule, you only read the figure A15 one time. In there, what you do is you define something called pseudocritical pressure and pseudocritical temperature. Pseudocritical pressure is found by this equation. You take the mole fraction of the component gas and critical pressure of the component gas, you multiply those two together, and you will take the summation of these values for all component gases, and you take this summation as the pseudo-critical pressure of the mixture. You do the same thing with the temperature, and then you use these two values to calculate the reduced pressure and reduced temperature for the mixture, and then you read the table to get the compressibility factor for the mixture. Then you can use compressibility factor equation to get let's say volume of the gas mixture. When it comes to calculating properties of a gas mixture, you can simply add extensive properties to get the extensive property of the gas mixture. When you are calculating intensive properties, what you have to do is you have to take the weighted average of the intensive property of the component gases to get the property of the mixture. When you are calculating the weighted average, you have to consider the units of the intensive property that you are considering. If the units of the intensive property is given as per kilogram, you have to consider the mass fraction. On the other hand, if the unit is given as per mole, you have to use the mole fraction. And also we discussed about Gibbs-Dalton law. The Gibbs-Dalton law is a useful law when it comes to considering ideal gases. Gibbs-Dalton rule says that when you are considering about ideal gas mixtures, the presence of other gases does not affect the properties of the gas of interest. The gas of interest behaves that it is in the temperature and volume of the mixture. Also, in an ideal gas mixture, enthalpy, internal energy, specific heat are functions of temperature only. However, entropy is a function of temperature and pressure.